Okay, so put it this way. Um, there's a lot of languages that do way better than what we use. In this case, we have admitted and accepted for a few decades that Java is one of the most horrid things to ever program in. Yet, guess what? Even up to date, to this day, it is still one of the top languages in demand for jobs and for people who know it. Although you'll never find it on like a top love programming language unless it's one of those biased one, like 95% of them, where it's like, oh hey, it's my favorite language, so it's everybody's favorite language. Um, I mean, no. If you find, for instance, on GitHub where they have like the most love language statistics, you'll never find Java on it. You'll actually find a lot of languages that are Lisp based or something like that. And also pure functional languages. And we've also accepted and admitted that pure functional is, for instance, better than functional, imperative, OOP, etc. Although one thing that we haven't accepted is that OOP, just kind of overall, the entire concept of isomorphism and objects is literally just fancy closures and fixed point functions from pure functional. That's no longer pure due to horrible, horrible methods of abstraction. We don't like to admit that, but that is very easily the case. If you learn a pure functional language and you write OOP, you'll realize just how simple it is to do. You don't even have to like write a method for it. Whereas, for instance, in a fourth, you do have to write an imperative 5 or 6 lines of code to create objects in. But that's imperative. It's a low-level imperative language. It uses the fourth paradigm with like a lot of virtual machines. So it's very weird. So it doesn't entirely count as a language in this case. And fourth isn't ever going to be popular. It's huge in Taiwan because they realize that, oh hey, we have a lot of issues with porting things and we have weird technologies and we can't just constantly just port and port and port. We're gonna have to rewrite a lot of code. And so some crazy dude was like, oh hey guys, here's a language, but it's in English. And so they're like, okay, crap, can we translate it? And so the guys are like, yeah. And so they got an English translator, and they just redefined all the methods as Taiwanese, and boom, it took just that, and suddenly, boom, you have an entire fourth language in a different language without having to do a lot of programming. And it's not higher level than the language; it's the exact same level. And so now, boom, they port to literally everything. They're swarming all of their technologies with Forth. It's very, very weird. And so they invented fast Forth after that. And Forth isn't perfect. It's never going to become the perfect language. The only reason I said for low level we'd use an ATS fourth variant is because ATS can behave like a fourth once it's lower level, so you kind of can just throw quotations and say, oh, it's ATS fourth, because it acts like the fourth paradigm. It has the fourth paradigm as its paradigm. Fourth paradigm, I'll explain in a little bit, not through talking. But anyways, yeah, so we admit all of these things are better. It's kind of like a lot of Emacs programmers you'll find will admit that Emacs is worse than Vim, and or vice versa. And okay, neither of them are perfect actually, so it's a bad example. But we know that test-driven is worse. But hey, for developers, it's better for them to make profits off of, because now you're getting way more money because you have to sit around and do all the extra work. Whereas if you were to just write types and do theorem proving, you just go yada 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 on a chalkboard and then look at it and say, okay, time to implement this. You implement it, you run it, it works, it proves exactly what your program is going to do. Suddenly, boom, there's no more issues. You don't have to worry about it. You don't have to go to unit tests. You don't have to write any more code. It's all done. And that's actually as well as the fourth. The reason it's not popular is because I can just write a subroutine, run the subroutine right then and there without compiling anything, and then saying, okay, boom, I'll move on to the next word. I'll fix a few of the bugs, and I'll move on to the next word. And you just do that. And so you're just sitting there storming your program with all of your words. And fourth is designed to where you're never going to have to use over 1,000 subroutines, or else you're doing something wrong. Even in a high-level even if you write a high-level language out of it, and then you write a video game in that high-level language, which kind of be weird, you're still not supposed to use over 1,000 subroutines. Heck, the JVM uses the fourth paradigm. It's a stack-oriented virtual machine, which means that it's a fourth it's a fourth virtual machine. I'll explain that later in a bit as well. Anyways, I'm losing time. I'm at 5 minutes. So yeah, what was I at? Fun. Oh yeah, even it doesn't use over 1,000 subroutines. You're never gonna find a fourth program that does that. It'd be a waste of time. So we know these things are better than test driven or than what we do things currently, or how we do things currently, sorry. But we don't choose to accept it because it's too difficult. It's, oh, hey, there's math that's harder than just 2 plus 2. I'm going to avoid that for the rest of my life and call everybody who uses it crazy because I don't want to do anything that's I have to learn too much. So things like category theory we use without ever realizing it. OOP is just a method of category theory and isomorphism. And it's just weird. All right, so we've admitted for years, decades and decades now, that Java is absolute crap. We don't want to use it. We don't like it. It's a nightmare for developers. But hey, it's still the top, well, one of the top right now, top demanding programming languages for jobs and people to learn. Why is that? Well, it's because Java can be ported quite easily. It's still crappy at porting. It's kind of like Electron, where you can port it quite easily, but not everybody even does multi-platform very much. I have things which are really nice, for instance, like, oh, hey, Minecraft. They don't have to port Minecraft to anything. They write Minecraft and they're done with it. The JV takes it and then boom. For that variant of that operating system now, there's Minecraft. And so they don't have to write any extra code, which is really nice for them. But there are other methods of doing porting, mostly actually in the form of bytecode languages and fourth-based stack machines like the JVM. So that's all cool, but now what's better than this? How can there be a language that's better than a language that can port via bytecode? Well, now you have to move on to languages that aren't just better with portability, but are better with bugs. And portability also comes in the factor of bugs itself as well. You can do a language without using bytecodes just by redefining a few primitives and then using an extensive based language system for that. For instance, if you write something in Lisp, you can literally just port that programming language by porting your variant of Lisp using Lambda as the only primitive, and just there's your entire program. All you got to do is redefine the primitive Lambda in that certain processor's variants, and boom. Same with Forth. I have an entire programming language. Now I just have to redefine the bottom level words, which there's typically about 4 to 12 of. It really depends. There's a lot of Forths. The Forth programming language is by far one of the largest I've ever seen. So whenever you look at it at whole, there's a lot of different Forth variants. So it really depends. Anyway, so next thing is bugs. We hate bugs. We don't like bugs. Nobody likes bugs unless they're enjoyable. But we hate testing for bugs. It takes so much time. Why should I have to write a program, send it to somebody, have them all test it, and send me the bugs that they found, whenever they can miss an infinite amount of bugs, and they'd never know. I'd never know. And then you release your program, and suddenly, boom, everybody's sending you an infinite amount of bugs. Like, oh, hey, this is a bug, this is a bug, this is a bug. You're just sitting there like, where did I go wrong? And so you do have to take that into account, that your program will always have bugs and that you'll never be able to escape that. And so unit tests just help you get the big noticeable ones that they see out of the way. They can also mistake something for a bug or think, oh, that bug's too minute, and skip it, although it's very unprofessional. I don't think they would do that, but that's still possible. If I was a unit tester, I could easily just not tell you a lot of your freaking bugs and you'd never know. And so we know that we can literally just mathematically calculate and prove that your function is doing what you want it to. For instance, termination. You can prove that your program will terminate in 2 different states of won game or lost game. For instance, if you win the game or you lose the game, it can terminate in those two instances. And so those are the only two variables you have to worry about. And you can prove that they terminate that very way. You can prove a lot of things, and there is type blindness, but in total correctness, you're not going to notice it very much. And in a Horror logic, you will only find it if you do not include the while rule. And even then, the total correctness of Horror logic is not as good as dependent types. There is actually a type-driven, a type theory equivalence, but still. And yeah, so we know these things are better, and we don't take this into account. We don't care that it's better. I like my Python. It's very, very short. No. So that's how people think. Because for instance, Python. It's not going to be able to ever do this, but hey, I like it. So or Java. It's not going to be able to do this, but hey, I like it. Even though Java is adopting a lot of functional things because it wants people to like it. But it's just doing so horrible. Same with Python. It's trying to be functional whenever it never can or ever will be related to functional, other than the fact that it is OOP. And that is another thing. OOP, we know it's flawed. We know it's crappy. We know it should only be used whenever we're actually dealing with objects. We don't like to admit it. It's just, oh, hey, it's easier for me. It's less math. And so, boom. That's our issue, is that everything that's good is math related. And that's, again, this is where people lose interest in things. It's, oh, hey, it's math. And I don't like math. I don't want to have to learn lambda calculus. I want to just be able to learn the words and make the words do things I want them to, not learn the words and numbers and make the numbers do what I want them to make the words do what I want them to. That's just too much. So yeah, and I realized that this Too Long Didn't Listen became just as long. So rest in peace me.